Uh, Hello everyone. Okay. Hello.
Hello,
Morning everyone.
good morning, sir.
Let's begin today's session. Uh, my slides are visible. Hello. Hello. Okay. So uh, let's begin today's session. So I'm Karthik Jadhav, research scholar in the Department of Water Resources Development and Management, IIT Roorkee. And currently I'm teaching assistant for the course Irrigation and Drainage. So currently we are at week number 7 of this course, and this course is basically designed by Professor Mailapalli of IIT Kharagpur. So yeah, these are my contact information. If you have any query related to the, any doubt related to this course content or any doubt related to what I've covered, you can directly reach out to this given email ID. Also, I would like to request you that if you have not watched previously uploaded or covered video, you can directly scan out this QR code and you can watch out it. And also you can access all the lecture materials as I'm uploading in this Google Drive folder. So yeah, we are at week number 7. So in this, like currently till now, we have covered about basic of soil water plant relationship. Then we have focused on water requirement by crops, water requirement by soil, and total water requirement, or it's called irrigation water requirement. Then we have come to design of irrigation system, and we have talked about various type of irrigation methods, and then we have come to conclusion that current methods that are available is like very inefficient, and they're using more water, and we need to conserve our water resources for future sustainable development. Then we have learned about new techniques or emerging techniques in irrigation sector like sprinkler irrigation system and drip irrigation system. So this combinedly both called as a micro irrigation system. So we have basically talk about its design aspects, installation aspects, operation aspects, and maintenance aspects. And then in last week we have started about like, okay, once you have designed our system, then if groundwater resource is the major resource in your region, how you can extract that water from groundwater. So for that we have talk about various kind of pumps. So sorry, so pump and everything we'll talk today. Last talk we have talk about basics of fundamental of groundwater, and that we have covered about confined aquifer and confined aquifer. Then what type of aquifer materials we have, what are their yielding capacity, how it's transfer the water from one place to one another place, and we have also uh, shown the quizzes, so like or problems that based on the this concept. And now we are at week number 7. So in this week, basically we are at we'll talk about so basically we'll talk about uh, pump and what kind of pump we have and what are their functions. Yeah, I would like to inform you that uh, lecture timing is changed from 10 a.m. to 12 p.m. on each Saturday. So as currently I'm in Germany, so like I'm trying my best to deliver all this content to you. So like due to schedule here I've changed the timing from 10 a.m. to 12 p.m. So that's I want to inform you. So let's start the today's session. So yeah, in week 7, so basically we have started with irrigation water lifts. Okay, so in general, it's classified as indigenous water lifts and pumps. So indigenous water lifts basically again classified in low head, medium head, and higher head. And pumps are generally classified as positive displacement pump and variable displacement pump. So in indigenous water lifts, so there are various kind of uh, methods and instruments available. So they are generally used in ancient time. So most common example are swing basket, down, Archimedean screw, water wheel, swing basket, chain pump, etc. And among these, this Archimedean screw is a very famous one, as it is more efficient among all these. And in terms of water lift, so generally low head water lifts is lift up to the height of 1.2 meter, while in case of medium water lift, so they lift to the height between 1.2 to 10 meter, and high head they're generally uh, lifting above 10 meter. Right. So apart from this, we have also talked about hydraulic ram. So it is a more efficient technique in case of hilly area. Right. So it basically utilizes the energy of a large quantity of water falling through a small height to lift a small quantity of this water to a greater height. So these are the this is the hand pump. So it delivers the constant volume of liquid for each cycle against varying pressure of head. So you can see hand pump and its components. So basically, hand pump we know that it's installed in a shallow aquifer where we have a shallow grounded table, and basically you generally find out in northern India where we have a alluvial kind of aquifer, and grounded is a very shallow, and you can see its different components, piston and everything. So you know that how it's operate, right? So once you'll pull it out, so it will like this. These are the piston kind of structure. So it will go above. So due to suction, there is a water coming in, and in next stroke, so water will come out. And these are basically about pumps. So different kind of pumps is there. So this is a hydraulic ram, right? So let's see here. So basically, pumps is classified as a positive displacement pump and variable displacement pump. So positive displacement pump, so it delivers constant volume of discharge against the stroke. So in this we have basically reciprocating pump and rotary pump. So reciprocating pump again classified as a lift pump and force pump, and both are again classified as single acting and double acting. While in case of variable displacement pump, we have a centrifugal pump, mixed flow pump, propeller pump, jet pumps, and among these centrifugal pump is the most common in the irrigation sector, and it classified as a volute pumps, diffuser pump, and turbine pump. Okay, so these are the different kind of pumps. So these are simple reciprocating pump, single acting reciprocating pump, has only two cycle of stroke, or like you can say one stroke. So there is in, and one stroke there is out. So one cycle of stroke discharge the water, and next to this, so in general, pump is defined as any device that uses to convert mechanical energy into hydraulic energy, right? So basically, what pumps do, so it converts mechanical energy. So mechanical energy in terms of electric energy, solar energy, or whatever energy we have. We can say diesel pump. So all that pump, by adding some fuels, we'll get energy. So that energy we are using to convert into the hydraulic energy. So basically, we are trying to extract the water, or we are trying to put water from one place to another place, so that have a different height, right? So basically, that mechanical energy gets converted into the hydraulic energy or pressure energy, you can say. And the first pump come into the picture is a positive displacement pump, right? So positive displacement pump, basically it have a piston or displacement pump, okay, and uh, uh, basically it provides the constant flow of each cycle of varying pressure or head. Okay. And after that, it operates by altering or of filling a cavity and then displacing a given volume of classification of positive displacement pump. So the most common one is a reciprocating pump. Then we have a rotary pump. Then we have shallow and deep reciprocating pumps, and we have talked about type of reciprocating pump based on construction and operation. So reciprocating pump in general, classified as a piston pump, plunger pump, and diaphragm pump. So basically, these are the mechanism through which the water we are taking out. And rotary pump generally classified as a gear, or also known as a lobe or screw or vane type of pump. And now in terms of different aspects, how reciprocating pump and rotary pump is a different, right? So in reciprocating pump, flow type is a pulsating. Pulsating, it means it is in a pulse, right? So like we have seen reciprocating pump here. You can see, so in one stroke, water is coming out during suction, and during pressure, water will go out, right? So it is not like that water is continuing out, continuous going outside during each stroke, or it is not a continuous uh, process, right? So it is a pulsating process. It is one of the major difference with the rotary pump. So in case of rotary pump, we have a continuous discharge. Okay. So this you can see, this is the rotary pump. Then we have in terms of pressure. So generally, reciprocating pump, high pressure, it operates at a high pressure, while rotary pump operates at a lower pressure and flow rate. Generally, lower flow rates in case of reciprocating pump, while higher flow rates in case of. So this is also major difference. So it is using high pressure, generally high pressure, while high pressure reciprocating pumps delivers low flow, while rotary pump it uses low pressure but it delivers high flow rates. Okay. And maintenance also, like reciprocating pumps require higher maintenance due to more moving parts, right? And it works at a high pressure. There is a high chance that its parts get damaged or there's a wear and tear. So it required continuous maintenance, while rotary pump it required comparatively less maintenance. In terms of efficiency, so reciprocating pump is have a high efficiency, especially at a high pressure. While rotary pump just have a good efficiency and it is versatile with. Sorry. Okay, so let's continue. So, uh, okay, yeah, so we are talking about reciprocating pump and rotary pump. Then now, uh, uh, once in last slide we have basically covered about positive displacement pump. Right now, let's talk about variable displacement. So in variable displacement pump, so it can change the volume of fluid they displace per cycle, altering the geometry of the pump's displacement chamber. Right now, so it covers power and flow both. And in this variable displacement pump, so one specific speed concept is a most specific speed concept is the most commonly used to as it is the index to uh, and providing operating characteristics. So basically it relates the speed, discharge, and head. So it is a dimensionless number that's at the speed at which geometrically similar impeller would operate to produce 1 unit of flow and 1 unit of head. Generally, based on specific speed formula. So this is the formula for specific speed. Uh, Positive displacement pump, sorry, variable displacement pump. So it is given by an S. So it is a specific speed and is equal to tan under root Q divided by H raised to 3 by 4. So based on the value, this value, if your specific speed came below 500, that is called low. It is categorized as a low specific speed. And if it is between 500,000, then it's called medium specific speed. And if it is above 1,000, then it's called higher specific. Then the law of affinity comes into the picture. So it is basically relationship between total dynamic head, discharge, and brake horsepower of the pump, and how it's related to the size of the pump. It means width, then speed of the pump, and diameter of the impeller. This relationship is given by this formula, right? So it is like quite common and very famous. If you want to design your variable displacement pump, specifically centrifugal pump, and it is given by Q naught is equal to N by N naught is equal to under root H by H naught equal to P by Q. So discharge and speed are almost directly proportional kind of relationship, while discharge and head, so discharge is directly proportional to under root of H and uh, cube root of power. Then we have talked about pump parameters. So pump capacity. So it is basically about flow rate, what flow rate it works on. Then suction lift, then static discharge head, then total discharges. So total discharges is combined of static discharge head, variable head, velocity head, pressure head, and other losses. Right. Then total static head, friction head, that all we have talked about based on the diagram. I'm not going into detail that part as we are going to solve this kind of question in question and answer session. So I'm skipping right now, and after that we have talk about net positive suction head. So basically, it is a very fundamental concept again to avoid cavitation kind of activity. Then we have a centrifugal pump, so specifically focused on that. So centrifugal pump is basically uh, have a two elements. So one is a rotating element and one is a stationary element. So you can see here, so impeller is a rotating element and vanes and diffuser are a stationary element. And basically like centrifugal pump converts it classified based on the type of energy conversion, number of stages, impeller time, and uh, other parameters. But basically, in general, it classified based on three criteria. So first one is a type of energy conversion, number of stages, and impeller time. Okay. So in terms of type of energy conversion, so volute and diffuser or turbine type are most common. So it basically convert the kinetic energy into the potential energy or pressure energy. And number of stages, so single stage and multi-stage. centrifugal pump. So it basically, if you have multi-stage centrifugal pump, so it basically delivered at a higher head as compared to single stage than impeller type. So it is like basically we are using based on the water quality of the uh, of which you are pumping. So it generally classified as open, semi-open, and closed impeller type centrifugal pump. And these are the factors that influencing the selection of size. So basically, fundamental criteria is discharge capacity of pump, source of water, and energy availability. And this is the general difference between volute type and volute type. So volute type, you can say it's cross-sectional area of volute that gradually increases and extends around the impeller. Right. So you can see this. So this is the volute casing, right? So this is the vane, then this impeller, then cross-sectional area of volute that gradually increase. You can see this area increase gradually as it extends around the impeller. While in case of diffuser type, so it is a stationary vanes diffuser surrounds the impeller. Okay. Then we have also talked about the valve characteristics and pump characteristics. So discharge drawdown characteristics and other things and pump power requirement. Now let's uh, focus on question and answer session. So still in between, if you have any queries till now, you can uh, ask me. Even know that. So let's take a minute break here. So we join again, and I will continue with this question and answer session. So okay, so let's continue the session. So question number one. Sorry. So question number one. Which of the following water lifting device is operated by animals? So swing basket, Archimedean screw, Persian wheel, and gear. So we know that water lifting devices are classified based on their mode of operation, right? So either it is a manual, animal powered, or electric. In general, it is also classified based on how, uh, what are the delivery head. So it is a medium, it is low, or it is high. Okay. Based on mode of operation, it is classified as manual operated, animal operated, or electrical. Electric powered. Now, manual device includes the simple traditional tools like swing basket, Archimedean screw, right? And animal power device such as Persian wheel, right? So they are asking about which are the lifting device operated by animals. So Persian wheel is the most common example of this. Other are other are similar to it, and it generally use the bullocks or camels to rotate the wheel or pulley. And basically, you can see this uh, bullock, right? And it rotates around it, and it's a mechanism. So it also this wheels also continuing rotates and deliver water from lower head to higher head. So Persian wheel is a classical example of animal operated water lifting device where animals walk circles to rotate the wheel and lifting water continuously in buckets or containers. Correct answer is option C. And gear pump, we know that is a mechanical electrical power of. Question number two, which principle allows lifting of water by creating vacuum in a chamber? So, lifting of water by creating vacuum in a chamber. We know that water can be lifted by several mechanisms or several mechanical principles. And atmospheric pressure can only raise water to maximum height of one atmospheric pressure, right? One atmospheric pressure is equal to 10.33 meter, okay, which corresponds to one atmosphere. Now, when a vacuum is created inside the chamber, atmospheric pressure acting on the water surface pushes water upward. Okay. This principle used in a suction when it limits its height up to 10.33 meter is because atmospheric pressure cannot support the higher water column at a sea level. So, correct answer is water lifting by creating vacuum in a chamber. So, it is done by atmospheric pressure. These are the classic example of kind of mechanism. So, it is hand pump, right? Similarly, uptake the water by creating vacuum and using atmospheric pressure. Correct answer is option. Question number three. Which category of water lift is used when lift height is more than 10? Low head, medium head, high head, positive displacement. So we know that low head is used up to the 1.2 meter, medium head 1.2 to 10 meter, and high head greater than 10 meter. And its example are centrifugal pump and jet pumps. And low and medium height devices are rely more on indigenous and animal uh, power, right? Answer is option C. Now, which of the following is a positive displacement pump? So we know that pumps are generally broadly classified as a positive displacement pump and variable displacement pump. So positive displacement pump which physically displays a fixed volume of liquid, while variable displacement pump which rely on velocity and kinetic energy. In general, so positive displacement pump discharge the constant volume of water, right? And it use the high pressure, while variable displacement pump uh, rely on the velocity and kinetic energy of fluid and or liquid, and based on that it discharges. So we know that centrifugal pump is classic example of variable displacement pump, and gear pump also it is a positive displacement pump, right? And it taps move liquid by rotating gears. Then we have a jet pump, so it is uses momentum transfer, and it works on impulse principle. And propeller pump again it is a variable displacement. Correct answer is gear pump. Okay, option B. So this is the gear pump, right? So there are two kind of gear pump: external gear pump and internal gear pump. External gear pump basically it attached at external side, while internal gear pump is attached side like gear. Okay. Question number 5. Reciprocating pump is best classified as so dynamic variable displacement pump. No, it is not variable. It is a positive displacement pump that traps and pushes fixed volume at each stroke. Right. So you can see this the suction stroke and compression stroke of a basic reciprocating pump design. So there are three kind of device. So it is a piston, a plunger, maybe gear kind of mechanism we are using in positive displacement pump. So most common is a piston pump. So in this we have a piston. So when piston goes up, so it sucks the water from inlet, and when it's down, so it pushes the water, so it compresses it, and there is a certain mechanism at certain pressure. This valves it's open and water will move out. So correct answer is option B. And these are the just little background. So I already talked. And fundamental concept is like positive displacement pump discharge is given by speed into swept volume per flow is governed by geometry and speed. Question number 6. Which statement correctly distinguishes lift from that? Before that, let's understand what is lift pump and what is uh, force pump. Okay, so lift pump is a classic hand pump with piston above water. So it is just like a hand pump with a piston above water level, and its suction creates a partial vacuum to atmospheric pressure, pushes the water out a pump barrel and out the spout height. By force pump, so it adds delivery or force valve and closed delivery line. So piston forces water into the pipe to a higher elevation. And the suction limit, so we note at the sea level, atmospheric pressure supports 10.33 meter of water is ideal, and in practice, friction, vapor pressure, and leakage reduce the usable suction lift. Uh, general, practically, it is around 7 to 8 meter only. So hence, lift pump cannot send water to a tank significantly higher than a pump. And a force pump can because pressure is generated on the delivery side during piston forward stroke. It can deliver at a higher height. So lift pump can deliver water to a tank above pump level, and force pump can. Wrong. And lift pump relies on atmospheric pressure and discharge up to only spout level, while force pump can discharge elevation above the pump body. So correct option is option B. Question number 7. A single acting reciprocating pump without an air vessel. Discharge through a delivery pipe is continuous with one discharge during every stroke. No, for single acting reciprocating pump, so it is intermittent discharge with one discharge stroke for every two stroke of piston, right? Because single acting pump has water on one side of a piston, right? The piston alternates between suction and delivery or discharge. So two stroke per cycle. So there is a in one in a suction and one which deliver the water. And discharge occurs only during the delivery stroke. And why others are wrong? So you know that it not continuous at high speed. It uses the high pressure, but it delivers a discharge rate. And though it is a highly efficient, but energy requirement is quite high. Question number 8. In a single acting reciprocating pump, fitting an air vessel on a delivery line primarily. So first let's understand air vessel. So air vessel is in a closed chamber partially filled with compressed air connected near the delivery line. And during the delivery stroke, part of water compressed. The air during suction stroke, the compressed air expands to maintain flow while piston pulls in a next stage. So acts like a hydraulic flywheel and storing and releasing energy to and reduce the flow pulsation more nearly steady discharge and also reduce acceleration here and lower power requirement and high vibration, and it does not change the swept volume suction limit and piston details. The correct answer is option D. Discharge smoothly and reduce the acceleration head and power fluctuation. Question number 9. A gear rotary pump is classified as. So gear pump, we know that it consists of two intermeshing gears enclosed in a casing, right? And as the gears rotate, the trapped liquid between the gear teeth and casing carrying it from suction to discharge side, the meshing at center prevents backflow, thus generating the suction. And we know that gear rotary pump or rotary pump generally comes under a positive displacement pump, and its principle is a fixed volume of fluid is trapped and moved each rotation here, and it produces the continuous and steady flow at low speeds and requires clean liquids since sand dusts can cause a wear and tear and also blockage in this kind of pump. So gear pump is a positive displacement pumps, not a dynamic pump, and they cannot handle sandy waters or like you can say turbid water or water with a poor water quality that have a lots of sediments in that. Hence, option B is correct. So it is a positive displacement pump using meshing gears. Then why is it recommended that water is supplied to gear pump be free from sand or dirt, right? So we know that gear pump flows tolerance between gears and emission. So it have gears, right? Internal and external, you can say anyone. So and any abrasive particle like sand, so water is moving like this from here to here. So whenever it will pass through this, so if it have a sand or dirt kind of material, if it is like this, then what will happen? So it will get stuck here in between, and it causes wear and tear. Also, it causes blockage, right? So this overall causes the reduction in efficiency of pump. It causes the leakage and cause the pump failure. So positive displacement pump rely on a tight clearance to minimize the slip, and abrasive compromise this leading to reduced missile capacity and pinch seizure. So the key issue is there is a mechanical wears of a gears, and there is a not a gravitation, right? So correct answer is to prevent the clogging obstruction by to avoid damage and wear of machine gears. Correct answer is option C. Question number 11. Diaphragm pump is particularly suitable for. So we know that diaphragm. So this diaphragm pump, and it uses the flexible rubber diaphragm to alternatively expand and compress the pump chamber. And check valves control the suction of fluid. So you can see the fundamental concept is no sliding pistons inside the fluid, okay, and no contact between moving metal and parts. Also, it can safely handle muddy water, slurries, and corrosive liquids without wear, and widely used in irrigation with. So, unlike the gear pumps, diaphragm pumps tolerate some mud and suspended solids because only diaphragm flexes, right? They are preferred for impure water sources. And why it is like that? So use the flexible rubber diaphragm, right? So this is the rubber diaphragm. So all kind of structures. So it is not cause to wear and tear, and have a different mechanism, and alternatively expand and compress the pump chamber. You can see like this, right? So this rubber ball is moving, and there is a no sliding position piston inside the fluid as a gear or the reciprocating pump. So there is a no direct contact with the metal, so it can safely handle the muddy waters, slurries, and corrosive liquids. Correct answer is option B. Can pump water containing mud or. Question number 12. In a diaphragm pump, water is displaced because of. So, uh, diaphragm pump water is generally displaced because of. So diaphragm pump we do that is mechanically or by crank or pneumatically operated, and it as it flexes outward, vacuum is created, suction valve opens, and as it flexes inward, water is pushed out throughout the discharge valve. And this is the positive displacement action, similar to piston pump, but with a flexible membrane instead of rigid piston. And fluid never contracts moving parts, so it can handle corrosive or dirty water. So correct answer is option uh, compression and expansion of flexible diaphragm, momentum of transfer and speed, atmospheric pressure. So correct answer is option right. Next question. Which of the following is not a type of centrifugal pump? So option A, mixed flow pump, jet pump, propeller pump. So centrifugal pump. So we know that reciprocating pump is not a type of variable displacement pump. It is a positive displacement pump. So in case of variable displacement pump, so it is a dynamic pump and it converts kinetic energy into the potential energy, which it includes the mixed flow, popular jet, and air lift pump. We know that it converts velocity head into the pressure head, and then while positive displacement pump, it have a reciprocating gear, diaphragm, piston, so that generally used to deliver water from place to another place. So correct answer is option. Next question: in a centrifugal pump, double suction impeller is mainly used to. So double suction impeller draws the water into both sides, right? You can see single suction impeller design and double suction impeller design. In single, only water is coming from one side, while in double suction impellers, water is coming from both sides of the eye of the impeller, and it's balancing the axial forces. And so generally single suction impeller, so we know that as it is coming from one side, so it caused the axial thrust, while double suction impellers so suction from both sides, so balanced thrust and higher capacity. So generally double suction impeller maintains the axial thrust cancellation and greater discharge for a large flow application. So correct answer is option A. Next question. In a centrifugal pump, a stationary element responsible for directing fluids. So this is a centrifugal pump, and centrifugal pump has two main components. One is impeller, and one is a casing. Right. So impeller is generally rotating part, while casing is a stationary part. So casing generally helps, as you can see, this area of this casing, sorry, is increasing towards as it's moving towards outlet. So it generally used to convert velocity head into the pressure head, right? And volute casing gradually increase area, and generally they are asking about a stationary element responsible for directing flow. So it is casing, right? Option C. Next question: what is the main function of diffusion vanes in a diffuser pump? And you see this impeller and diffuser type of pumps. So diffuser. So diffuser pump surrounded the impeller with a fixed guided vane. Water leaving the impeller at high velocity, and diffuser casing, so it have a better efficiency than a volute, especially in a multi-stage pump. And it works on a Bernoulli principle, so it converts velocity into pressure. So diffusion waves slow down the water and increase the pressure. Okay, so it is in case of volute we have a increasing in area, cross section area towards outlet, while in case of diffuser, so there are mechanisms, so that mechanism slow down the velocity, reduce the velocity. So reduction in velocity increase the pressure. So its main function is velocity to pressure. So option B is correct. So reduce the velocity and convert kinetic energy into the which type of impeller is the most efficient and commonly used in large? So, there are different pump are given. So open impeller, semi-open impeller, and closed impeller. So which type of impeller is the most efficient and commonly used? So open impeller, we know that it is a simple and less efficient and generally used for dirty water, poor water quality water, and semi-open. It is a moderate efficiency and used for mixed or like dirty fluids. That is too much dirty. And closed impeller, it is fully closed and have higher efficiency and widely used for a large pump and a clean water. So correct answer is option C. Right, closed impeller. So it are generally used for large pumps, used for clean water. Then cavitation in centrifugal pumps occur when pressure inside pump rises above atmospheric pressure. Pump speed is too low. Local pressure fall below liquid vapor pressure. Suction lift is less than time. So when so just a second. When local pressure below the vapor pressure, so liquid vaporize a vapor bubble and bubble collapse in high pressure zones, causing a noise, vibration, and damage. You can see this damage that occurs in the centrifugal. There it's the different parts, so impeller and casing that can be that can get damaged. So cavitation generally reduce the efficiency and damage the impeller surface and avoided by maintaining sufficient net positive suction. So the key trigger is vapor bubble formation is due to the lower pressure that is below the vapor pressure of flowing liquid. That lowering in pressure causes the evaporation or bubble formation, heating of the liquid. So correct answer is option C. Local pressure falls below the and next question, what does the net positive suction net physically represent? We know that net positive suction net is available and net positive suction net required. There are two concepts and determined by the available is determined by the system while net positive suction required is specified by pump to avoid cavitation. So in general, net positive suction head available is always less than that positive suction head required. In that case, if it is like yeah, so sorry, so if the whatever net positive suction rate required is greater than available, right? So in that case, cavitation will occur. So correct answer is option B. The pressure head at pump junction above the pressure of liquid that uh, this net positive suction. So this is general like about cavities and other things. We'll go through that quicker than on a centrifugal pump characteristic. The point of highest efficiency is called so we know that it is called cutoff and break best efficiency was it is correct answer, right? So pump curves plots between just generally head versus discharge efficiency versus discharge or power versus discharge and best efficiency point it is operating point with the maximum efficiency and it's running far from best efficiency point. So this is the general curve, best efficiency curve. So it is not like that when you get higher head and flow, it is the best. It is nothing like we also need to check about its power requirement as well as efficiency of the pump. So this combining this head discharge, efficiency discharge, and power discharge curve, we can plot, we can identify the best efficiency. Correct answer is option. Which factor most strongly influence the monthly cost of running a centrifugal pump? So operating cost is for centrifugal pump is based on energy consumption. We know that energy cost is P in into P into cost per unit. So even with the same pump, operating hours and input power dominate the correct answer is water, input power and operating hours. Option C. A match of the following entries. So dawn. So we know that dawn is generally operated by a single person. Swing basket it required two-person. That's reciprocating pump. So it basically have a plunger in that. Then uh, hydraulic ram. So it is also known as an impulse pump and counterpoise. So it uses the weight at end of the rod. So these are the different. This is a spring basket. This is the dawn. Then you have counterpoise, hydraulic ram we have already shown. And then next question, positive. So these are the group A, and we again need to match it to B. So positive displacement pump. So we know that it provides a constant flow regardless of a pressure variation in the system and making them reliable for steady flow application. So it is a constant flow. Then variable displacement pump. So it allows for adjustment of flow rate by varying displacement or cycle, so it is a variable flow. Then rotary pump, so it often includes the components like idle gear, which helps in the smooth rotation and movement of the fluid through the pump. Rotary pump have a ideal gear, so gear in that, and we have a duplex pump, so it is characterized by having a two pistons or cylinders lined for continuous and more efficient pumping with reduced pulsation. So there are two pistons or two cylinders. So it basically allowing continuous and more efficient pumping with reduced pulsation. Then we have a centrifugal pump. So centrifugal pump have an impeller. So it is best method. This is the correct answer. Then this is about again single acting, double acting. So I'm not going into detail. I already explained it already and go through this question and let me know if you have any doubt. So these are the reciprocating, single acting, double acting reciprocating pump. Then we have a gear pump. Volute and diffuser are types of, so it is a type of centrifugal pump. We know that volute type generally cross-sectional area of volute gradually increased towards as it expands around impeller. While a diffuser type, so we have a diffuser at end of impeller. So it is a set of stationary valves diffuser surrounds the impeller. It basically reduces the velocity of water and it generally converts the velocity into the pressure. Which of the following factors significantly affects the efficiency of hydraulic ram or hydram? So generally hydram, sorry, so this is the hydram, you know. Right? So hydram operates on the principle of water hammering or inertia pressure which develops when flow of water is suddenly altered by a closing a valve. So you can see this. So initially water will go inside this. So this is the delivery side and this is the waste side. So you can see there are valves. So initially water will go in this, and if there is enough pressure is developed, so this valve gets open and delivery water will deliver at desired location. So for this inertia pressure to be maximized and the supply needs to be long enough to allow water to build sufficient momentum before valve. If the pipe is too short, so water won't gain enough speed and momentum. So it results in a lower pressure and consequently lower efficiency of the pump. So basic things is we require the higher length of water movement, right? To provide sufficient momentum before valve close. The correct answer is length of the supply pipe. It is the main criteria that significantly affect the efficiency of hydraulic ram or hydram, or also known as the water hammer, as it works on a water hammer principle. So yeah, this is the hydraulic ram. So it is utilize the energy of a large quantity of water falling through a small line, and it generally requires a higher delivery side supply line, provides sufficient momentum, water gets delivered at suitable location. Yeah, so this supply pipe, then we have a delivery valve or rising main. So basically, this pipe should ideally be long to maximize the kinetic energy. Then waste valve, so the flow of water leads to opening of a waste valve at the bottom of the ramp, and water initially exits through this valve, waste valve. It is designed to suddenly close when water reaches a certain velocity. So if that critical velocity reached by water, so this valve gets closed. Then this delivery valve gets open. So due to increasing in velocity and pressure, and deliver the water. So it works on a water hammer effect. So when what is that? So when the waste valve closes suddenly, right? So when at critical velocity reaches, so it valves get closed and it creates a high pressure spike in the system known as a water. This is due to the inertia of water, and moving water does not have enough time to gradually slow down or stop, so it compresses. Next question: what factors determine the capacity of reciprocating pump? So capacity of reciprocating pump is determined by the size of cylinder chamber, length of stroke, and speed of the stroke. So correct answer is option B. Size of cylinder chamber, length of stroke, and speed. All determine the capacity of reciprocating pump. Which of the following is a primary mechanism used by shallow well reciprocating pump to rise water? So shallow well reciprocating pump primarily use atmospheric pressure to rise the water, and when the piston is moved up down by a movement of handle, it displaces displace the air from pump column. It creates the vacuum allowing atmospheric pressure to push water from well up to the pump column. Correct answer is option. The point of interaction of H and Q curves of the pump characteristics and system curve is known as uh, the operating point or duty point of the pump. Right? You can see so in head versus discharge. So intersection of head discharge, the pump characteristic curve and the system curve is known as pump operating point. So option D is the correct answer. And this point represent the flow rate and rate at which pump will operate in a system. It is an equilibrium point where heat developed by a pump matches the heat required by a system. It is a very crucial during pump operation to identify this pump operating point so it matches equilibrium between heat developed by pump and heat required by system. And which of the following statement is about net positive suction head is correct? So, net positive suction head is a crucial concept in the centrifugal pump system and it relates to the pressure condition on the suction side of a pump and determined by a suction nozzle. So, connected to the pump center line minus the vapor pressure of liquid at the pumping temperature and both expressed in meters. The correct answer is option C. So NPSH is a total suction head determined at suction nozzle. So it is a total suction head minus vapor pressure, that is VP, at pumping temperature. So this is about uh, NPSH, right? So let's take a 5 minute break here. We have a few questions left. I'm really sorry. Like there are no people in meeting. That's why there is a we will get disconnected. And still, I'm recording this session, so there is a no worry in that. So let's continue our session. So next question is which factor does not influence the net positive suction rate available in the pump system? So I'm skipping this question. So go through this easy one, and I've also explained everything about NPSs and centrifugal pump in detail. We have discussed already, right? So go through this all and simple question. Now let's focus on a numeric type of question. So first question is a centrifugal pump discharges 6.5 liter per second against a total head of 40 meter. When speed is a 2610 rpm, the specific speed of pump is we need to identify. So discharge is given is liter per second. So first we know that specific discharge NS is given by formula that is Q into uh, Q into it is discharge into head and divided by NS NS that we need to identify is equal to power raised to by so Q let's convert the meter cube per second. It's all are in metric unit meter per second. So just convert it into the uh, okay. And let's put everything in this formula. So you'll get the correct answer. Next question is about farmer has a 4 hectare area under sugarcane crop and 8 centimeter irrigation is required in interval of 7 days. Electricity available is for 8 hours in a day and required discharge capacity of pump liter per second. So we know that total volume of water required for one irrigation is equal to area into irrigation dam. So it will give us a volume required. So it is a 3200 meter cube. And if we'll calculate the total time available for irrigation in 1 week, so just let's convert that into the a second. So we'll get required discharge in liter per second or meter cube per second. So correct answer is 15.87 liter per second. Okay, so next question. So it is about the power requirement. So I think this kind of example question we have already covered, and as on the time I think uh, and so yeah, let's cover this since this is the last question. So and then we'll take certain doubts or question if you have. So a pump lifts 88 uh, 1080 liter per hour water against total weight of 50 meter. Pump has efficiency of 72% and direct drive electric motor having efficiency of 80% is used to operate the pump. So we need to calculate the kilowatt input of electric motor is dash. Q is given in liter per hour. Let's convert it into liter per second. Then height against its delivery is 50 meter. Yeah, pump efficiency is 72% and motor efficiency is 80%. So we know that water horsepower, that is the first we need to calculate. So it is a discharge into 8 divided by 76. So discharge is given as 20. So in this formula, basically if you want water horsepower in a horsepower unit, so discharge must be in a liter per second, head in a meter, and 76 is just conversion. So we have a value of Q in liter per second, head is in meter, then at 76. So we'll get water horsepower is 16.10 horsepower. And if we divide this water horsepower by pump efficiency, because after whatever power we required, so first pump will come to take water out, then motor is there, right? So first to get the brake shaft horsepower, we required uh, water horsepower to get divided by pump efficiency. So shaft horsepower is must be equal to 22.36 horsepower. And since the pump is a direct driven, shaft horsepower is same as a brake horsepower, therefore final total power requirement input power requirement in motor is brake horsepower divided by uh, motor efficiency and just multiply by 0.746 because we want this in a kilowatt. So this is in a kilowatt. So we know that 1 horsepower is equal to 746 watt or 0.746 kilowatt. Correct answer is 20.6. Okay, so thank you so much. And any question right now or any queries till what we have covered? I think no one is here. Okay, no worries. So you can, if you have any query, you can directly write down to the provided email ID here, right? And I will upload this content on this YouTube channel. So I request you to watch out and access a lecture material through this drive link. And yeah, so basically in this lecture we have covered about pump, right? Water lifting device. So there are various kind of water lifting device, whether it is manually operated, animal operated, or a pump operated. So basically it is a power obtained from electric or any mechanical device. Then we have specifically more talked on positive displacement pump and variable displacement pump. And in that also, basically we are focused on centrifugal pump. And then what are the problems that we have faced due to cavitation? Then we have net positive suction, net concept. And finally, we have solved certain questions that relates to it. With this, we have ended this lecture by solving multiple question, multiple choice question, and numeric type of question that we have learned in this week number 7. With this, I'm ending this session here. So once again, thank you so much for joining and watching out this video. So yeah, thank you.